Okay, thank you very much. I'm Fabian, I'm the manager of the QML team, and I'm going to preach to you the benefits of QML modules. But before we start with that, how many of you are already using QML modules? Quite a few. I'm preaching to the choir today. How many of you are using QML modules with CMake? Slightly less, but still the majority. So you don't have to know anything about QML modules before the talk. You will see some CMake code, so some familiarity with CMake is helpful, but I hope you could even follow if you're not using CMake yet. So without further ado, let's go to the meaty part. Why should you use QML modules? If you ask that question around, you might get different answers. Some people will tell you with QML modules, you will get a tooling support. Some people will tell you it makes your code run faster, which is also great. And some people give you the cheeky answer, well, with Qt 6 you really can't not use them, so you're kind of out of luck. But my answer to the question is, it makes your life easier. Now, if you haven't used QML modules yet, that sounds great, and you want to use QML modules. If you already tried to use QML modules, you might say, Fabian, easier? Why is something which is easy taking 40 parameters of arguments? What even is a QTP? And didn't all of that work quite well in Qt 5 times without modules? So today, I will first of all tell you what QML modules are, and then we will look into a few places where they can help you, and hopefully that will convince you that they indeed make your life easier. So we will start with some basics. Okay, what are QML modules? If you look into our documentation at a very abstract level, it's a mapping from names to entities. That's totally true and totally unhelpful. So what does it mean in practice? Let's take a look. The easiest part is you have your normal QML file, you do an import statement, and now you have some my button, and you can probably guess, well, that must come from my.module. So far so good. You can do the same imperatively in QML by using, for instance, create component that also works with module as a base. And modules are not only a concept which exists in QML, it also exists in our C++ API. You can access singletons by the module and name, and you can use load from module to instantiate any type. And the great thing about that API is that for the most of it, you don't really need to care what my button is. Is it a C++ type? Is it coming from a QML file? You don't have to care. Like, you don't see any URL like you might have seen before. And with Qt 6.9, you can use it everywhere, even in QQuick widget. We forgot about that one before, but that's covered too. And that's great as a user because it makes your life easier. You don't have to consider where your files are, what is C++, what is QML. But how does it actually work? Like, how do you do a name mapping when you only have an import? For that, we need to consider the concept of import paths. So first, when you have an import, we have to consider the URI. In the URI, we do have a dot. And by replacing all dots in our URI, we get a subpath. Like, if there's no dot, obviously you only get a single identifier, but okay, so that gives you a subpath. And what is the subpart? Well, there's also something called import paths where we are trying to look for it. There is a list of standard import paths. That's not the complete list, but that are some of them, which are always available when you create a new QML engine. And you can also add your own custom import paths via add import paths in QML. Once you have your list of import paths and the subpaths that you constructed from the module UI, we can do lookups. Like, Is our module inside custom path? Well, no. And then we just continue until at some point, well, we finally find the module. By the way, it is quite helpful because it means you can insert another additional import path and use it for mockups. Like instead of using your real C++ module, you could add another import path where you can find a type of the same name written in QML because it's quicker to prototype and it will load that one instead of anything coming later. Just as an aside. But I mentioned find a module. What does it mean that we find a module? Let's take a closer look at what's behind the path. So in general, we expect to find a few files there, probably a few QML files. But the really important part is the QML file. Like that's the vital part which makes a folder a QML module, if it's in an import path. And in that QML here, we can see a few directives, like we can see set module directives at the start. We can see a listing of various QML files. And we have some specialities, like our file a singleton is, surprise, surprise, exposed as a singleton. That's why there's also a singleton keyword in that QML here. And one maybe minor point, but just to stress it, the file name is not directly relevant. So if you look at that file, we actually expose it as custom type in the last line in our QML here. So you can rename stuff if you really want to. Normally I would say don't do that, but if you are inclined to do, feel free. And one important point here, that's all you need to create a QML module. A folder with a QML dir inside an import path. No CMake, no C++, nothing except for that folder. But you might not want to write a QML dir yourself, and if you have a larger project, you probably have a build system anyway. So how does that look in CMake? So initially, we need some boilerplate, which I skip here. But the important API is Qt@QML module below. And there we can give a few arguments like CURI, which is important because it's like the unique identifier of that module and which is also used in the path. We can then list our QML files, which for this example reside next to the CMake file in our source folder. We just list all of them. And in the last example, we had two additional things, like we had a singleton and we had a file which is renamed, and you can achieve that by setting file properties on the individual files. That's a bit verbose, but you can, if you want to make multiple files a singleton, put them all in a single call, and hey, you don't want to rename files in general anyway, so that's not too much of an effort. And in this case, we are using, as a first argument to Qt@QML module, we are passing a target, which was created by Qt@executable. So we want to basically create an executable application. And obviously, the next thing we want to do is to run it. And do you believe it works? Who believes it works? Show of hands. Yeah, nobody trusts me. Come on, I told you it's easy. If you run it, it totally works. And now you might wonder, okay, but you've been droning on about import paths and you haven't seen any import paths here. Like, how does it actually find the files? Well, we place all of the module inside a default import path, namely secure C1 Qt::QML. Easy, like I told you. Except there's a slight caveat. So like it's in the resource system, except you need something called QTP001. That's a so-called Qt CMake policy. And I could tell you about setting individual policy, but there's a much better way. You can just use Qt standard project setup. and tell it to require at least Qt 6.5. And my snippet shows 6.8, sets intentional. You should use the highest number you can. But if you are stuck with 6.5, all of the functionality is already available there, and you can just use 6.5. The issue is if you do require 6.8 in a 6.5 project, well, it requires 6.8, so it will error out. And if you want to learn more about that policy, you can follow that link. And I will have a few more QR codes later in my slides. And if at some point you miss them, that's not an issue. You will get the list of all links at the end of the presentation. And later there will also be the slides available on that address. But let's continue. I've told you everything works. You can just run your application as long as you use that policy. Except when you want to bring a bit more structure in your project. Like normally you don't want to place all of your files into the folder next to your CMake list. I mean, we are professional software engineers. We don't want to just dump everything into a folder. At least most of us. And so you might want to create some structure. You want to have a folder with all your QML files. And in that folder, you want to have buttons. Like a subfolder with buttons. And when you do this, you might run into a slight issue. Let's take a look at mybutton.ui.qml. And there we are using our singleton to get the default font property, because that's like where our config is. And what you do not see here is an import of our module. It's kind of natural because it's part of our module. Why would we import our own module if it's part of the module? So how did that work before? Well, there's something called an implicit import, which means we look into the directory level in which our file resides for a QML idea. That worked really great before because everything was in the same folder. Now we do it again. Can you see a QML idea here? Well, I can't. That's an issue. Your font will not be found. And with the font, there you get a different font. Like your designers will hate you, but it still runs. With something more fundamental, application crashes. Not so good. So, what's our solution? More QML ideas. And because you didn't like to write QML ideas manually before, we will auto-generate them, and they contain only one directive. So they are not full-blown module QML ideas. They just contain a single line. Prefer my module. And that makes it work, because then instead of looking into the current directory level, it will look in the top level module directory, and everything will work. So, before the implicit import failed with subfolders, but we can solve this by using more QML ideas. And because that is painful if you do it manually, you can enable a policy, and we will do it for you. And because you don't want to enable individual policies, because what even does the number mean, you just say requires 6.8, and you can learn more about the policy under that link. Now, this time you really need 6.8. So some of you might still be using 6.5. Are you out of luck? Kind of. You can't use prefer directives because they only work in 6.8. This is, however, a little trick. I don't put it into a slide because I don't want to promote it. But if you replace the prefer directives with an import of the module, like just import my.module, that mostly works. In 90% of the cases, it breaks if you're using internal QML types, but come on with using internal QML types. So you have to write it manually, and you have to use import instead of prefer, but you can find a solution. But consider upgrading to 6.8. It has many benefits, and one of them is that policy. And so far we have only seen QML. But what about C++? For C++, Qt.QML module is still your friend. You have to add an additional argument, sources, and in your QML files, you have to add the declarative registration macro. I'm not going into type registration in C++. There is a talk from Ulf from, I believe, 5 years ago by now. It changed a bit, but basically the idea still stands. You just add that kind of macro to your files, and we will pick it up and expose it to QML. And now let's take a slight look behind the scenes what we do. So what will happen is you have your files, C++, and we are going to run mock on them, which you need anyway, because that's how signals are implemented. That's how you get your meta object set up. That's not new, but we are not only generating C++ code for your signals and so on, we are also generating a new file called metatypes.json. That then will be picked up by QML type registrar, and from that we will generate two things: QML types, which helps tooling to understand what your module contains, and some registration code, which actually ensures that your type is available at runtime. Now, should you care about this? No. Like, that's detail. We are doing the job for you. You shouldn't really care about it. But you should recognize this relies on mock running, and it relies on that metatypes file being generated. That means you really should have automock enabled, because otherwise mock might not run. And you really want to use Qt.executable and not at executable. Same for Qt.library and not at library, because unless you do some additional setup, the metatypes.json file will not be generated. At least not in all versions of Qt. But other than that, you don't really need to care about the internals here. And now, so far, I've only shown you an example of an application. But what about reusable QML modules? Like, you might want to have a module which is used in more than one context, or which is not directly tied to your application. And that's actually the default case. Like, if you don't have a pre-existing target, it's the same as creating a library target and using that for your module. And we do one more thing, which might sound familiar to anyone coming from Qt 5 and the way we worked with QML in Qt 5. We are also going to generate a plugin. And with that, we can take a look at how the plugin is used to make your module available to an application. And that looks like this. We do have our application. Somewhere we have the plugin, hopefully in a path where it's actually found. And the plugin links to the libraries that we are also generating. Now we run our application, and at some point it will look for the module. It currently doesn't know about it, so it will look for QML plugins. We'll look for the plugin. Hopefully it will find it. Once we find the plugin will be loaded, and at that point we also automatically load the library behind it, which will run a static initializer. That makes the type registration available to QML. Nothing happens afterwards with the plugin. The QML engine will pick up the registered registration code and will run it. And then you can use the types. And if you look at this, the plugin doesn't really do much here. Like, it just gets loaded to load the library to run a static initializer there. Can we do it in a more simple way? Yes. We can completely disregard the plugin, directly link against the library. Then at application startup, we run a static initializer which registers the registration function. So it doesn't register the types already with QML. It just tells the QML metadata stuff that, hey, there's a module. If you want to actually use it, run the registration code. So once we look for the module, we know about it, we can run the registration function directly, and we can happily use our types. Simple, great, except when it's not. So do we really need plugins? Well, first of all, if you are directly linking against the library and everything is working, no, you don't really need them. They are not necessary by default. You can also, for that reason, disable plugin generation if you really don't need it. They are, however, still useful because you might want the QML CLI utility to execute your module. And in some rare cases, you currently need plugins because you want to register an image provider and you need to use it in Initialize Engine. And there's unfortunately a stupid bug which causes a linker to disregard secure linking against the library if it only uses the static initializer, because like linkers are C technology. Constructors didn't exist back then, so static initializers might be disregarded. I do have a fix for that, but currently you might be hit by that bug, and in that case, the plugin still acts as a fallback. And you get a few more benefits, like that concludes the part about plugins. And if you do all of that, you also get a few benefits for free. You get integration with the QML linter, which helps you find mistakes at compile time, not at runtime. You can use your favorite IDE for QML. So I've picked Kate, not only because like I'm a KDE developer and that's how I started with KDE, but also like we as a Qt company don't do any work on Kate, for better or worse. And it still works because it makes it possible to use the LS protocol. And so any editor can work with QML, with QMLS, as long as that auto-generated QML types file is available. And also we will automatically run the QML script compiler, which converts part of your QML code to C++ to make it run faster. And that's some benefits you get for free. And now we go to the next section where we look into a few more advanced use cases. We are not going to do a deep dive into them. I just want to showcase you a few things you can do with QML modules. So if you have a larger project, you don't only have one QML module and one executable. You probably have multiple separate QML modules, and you might have like a unit test, and you might have your main executable, and both of them should use both modules. And in general, that should still work, because at runtime, if the linker doesn't disregard your initializer, everything will be in the Qt QML subdirectory in the resource file system, and everything will be found at runtime. If you want our great toolings that I just promoted, you are, however, a bit out of luck because everything is in separate places when you build it. And to fix issues you might see there, you can use something new in Qt 6.8, which is dependencies, but with a target. So before you could already use dependencies and pass the module UI to it. But with 6.8, you can also say target, the name of the target of the QML module. That will help tooling to set up stuff to find your QML types. It will do an add dependency on the target so that when you are building your executable, it will actually build also the QML module. And in general, it's a good idea to use that API. And I forgot to mention that this also requires a policy, of course, like all good things. But you can also use Qt add executable. Qt standard project setup requires 6.8. Next, another use case. Also for larger projects, you might have a library, and you might want to support multiple applications, like widgets applications, and QML applications, quick applications. In the diagram, our library is using libQML because we need the type registration and so on. And for the QML application, everything is fine. I mean, there we need libQML anyway. However, if you look at the widgets application, the reaction might be like that. And that's mostly a joke about widgets, people having strong opinions about QML. But there's also a real drawback, like you have a widgets application and suddenly you have a dependency on QML. You have another entry in your SBOM file, you have another thing in your tool chain, you have another 13 megabytes of code, which you might not want to ship. So what can you do? Well, you just introduce a wrapper, like you put your main logic into your library and you create a wrapper, which you can do with QML foreign, where you expose every type from your library, and that's terrible. Then you need to manually keep it in sync. You add a file to your library. Oh, you need to add a wrapper to your QML wrapper too. Not great. We can do better. So before we had our object and it uses type registration, so we need to use QML to get the QML registration header so that the macro is known. Now we do a slight change. Instead of using QML, we are using QML integration. Nothing else changes here, but now we are using QML integration instead of QML, and QML integration is a header-only library, which is also part of Qdeclarative. And that avoids the dependencies, the hard dependency on QML. Now you might still wonder, okay, but like this still needs to be some work to be done to actually register the type. And for that, you need one additional command in your CMake file, which is qgenerate foreign QML types. How does it look like? So you create your actual library, which needs to link against QML integration. That's a header only. You then create your QML module, and then the vital step, you call qgenerate foreign QML types, which will collect all annotated types from your pure non-QML dependent library and add them to your QML module automatically. And that works for any basic type. It doesn't work if you actually need Titan integration, because like if you have a QML list property that's still in declarative, or if you want to do some extension of types, or if you want to call QML context to do some context manipulation for whatever reason, you obviously still need QML. But if you have a simple type which only exposes like a string and some int, there's no reason to make a hard dependency on QML. You can just use that way to solve that. And if you want to know more, this again a link to the documentation. The last part I'd like to mention is deployment. So you have your application and you want to deploy it to your users. How can QML modules help you there? So you have to do the usual CMake stuff, which is like install target. And then you have to do some rather lengthy command, but which actually does quite a bit of work. So I'm actually not going into all details here, but it helps you to create an install script for CMake. And once you have that, you can run CMake as before. You can run Ninja as usual to build your project. And then you can run Ninja install. And everything works. Everything? Well, everything on Linux, macOS, and on Windows, if you have an application. If you want to do Android development, it doesn't help you at all. For Android development, you have to follow that link, which is currently separate. if you're doing iOS development, and I know one person here who does, you are currently a bit out of luck, but we are working on it. That's the one thing I can promise. And moreover, if you want to deploy a library and not an executable, you are currently also out of luck. You can come after the talk to talk with me, because there are also some plans, but that's still in the making. And with that, we can segue to what's next. So, installation. Yes, it works for applications on desktop. Would be great if it would work also somewhere else. And for libraries. So, smoother deployment on all platforms for both applications and libraries is in our roadmap. Another thing we want to support is a reduction in build times, because, hey, it's great that we compile your code to C++ and it runs faster. But if that means that you become caffeine addict because you have too much time for drinking coffee because your code doesn't compile fast enough, that's also not great. So we are looking into that too. And that's like the main points we are looking into the future. But if we want to change what we are looking into, you can use the opportunity here to steer us into a different direction too. With that, we can come to our summary. What have you seen? I've shown you a bit what a QML module actually is. I've told you that it makes your life easier as long as you're using Qt standard project setup requires 6.8. I went a bit into how it works for C++ and how it relates to plugins. And I listed a few benefits you get out of it. And with that, we are done with the talk section and can open the stage for Q&A. Thank you.